Our next lesson is dealing with section 4.9, which is the combination of derivative rules. In this section, we're going to combine all of the different differentiation rules we have, and lots of times it's not so much the calculus that's difficult, it's more so the simplifying that causes grief. So let's take a look at this first example. You notice we have two functions that are being multiplied together, so we're going to have to use the product rule. But when we take the derivative of each individual function within the product rule, we're going to have to use the chain rule. So our governing rule is the product rule. So again, the product rule, to take the derivative, it says it's the first function the way it is, so it's x squared plus 1 cubed times the derivative of my second function, which I have to use the chain rule. So the 4 comes out front. The 2 minus 3x drops to a power of 3, and then I must multiply it by the derivative of 2 minus 3x, which is negative 3. And make sure you put that negative 3 in brackets, because otherwise it's going to look like a subtraction. So there's my first function multiplied by the derivative of the second, and then it's plus the second function, which is 2 minus 3x to the 4th power, times the derivative of the first function, which again I have to use the chain rule. It's going to be 3. X squared plus 1 drops down to the second power, and multiplied by the derivative of x squared plus 1, which is 2x. I am done with calculus. Okay, so I'm done with calculus at this step right here. The rest is now algebraic simplifying. So first of all, I'm going to multiply the negative 3 and the 4. So this is going to equal negative 12, and then I'm going to write the x squared plus 1 cubed, and then the 2 minus 3x cubed. Then I'm going to go plus, and over here I can multiply together the 3 and the 2x, so that's going to give me a 6x. Now I'd suggest writing the factors that are left here in the same order that you wrote them here. And I'll explain why in the next step. So I'm going to write the x squared plus 1 squared. And then I'm going to write the 2 minus 3x to the 4th. Now all we're going to do is we're going to take out the greatest common factor, because I really have two terms, one here and one here. So if you notice, we have a 6 that we can take out of negative 12 and 6. So I'm going to take out a 6. As far as x squared plus 1s go, I have 3 of them over there, and I have 2 of them over there. So I can factor out an x squared plus 1 squared. And I have 2 minus 3x's here. I have 4 of them there. So that means I can take out 2 minus 3x cubed. And let's see what we have left now when I factor that out. 6 goes into negative 12. I'm going to take a negative 2 left. I've taken 2 of these out, so that means I have 1 left. And I've taken all of these guys here out, so that's gone. Plus, now when I factor a 6 out of the 6x, I'll be left with an x. I've taken 2 of these out, so that's gone. And I've taken 3 of these out, and I'm going to be left with 1 of those. Now, by factoring out my greatest common factor, that allows me to simplify this. So if we go to our next page here, I'm just going to carry down the 6, x squared plus 1 squared, and the 2 minus 3x cubed. And now I'm going to distribute my negative 2 to get negative 2x squared minus 2. So that becomes negative 2x squared minus 2. And I'll distribute the x to get 2x minus 3x squared. So plus 2x minus 3x squared. And now I just collect like terms in here, and that would be my final answer. So 6 x squared plus 1 squared times 2 minus 3x cubed times, if I collect like terms, I'm going to have negative 5x squared plus 2x's subtract 2, and that should be my final answer. So again, if we look back at the original question, okay, I notice it's a multiplication, so I use the product rule, but when I take the derivative of each term within the product rule, I end up getting having to use the chain rule. Okay, let's go on to the next example. So in this example, we have a quotient raised to a 6. So the first thing I'm going to do is I'm going to use the chain rule, and then when I take the derivative of the inside, I'm going to have to use the quotient rule. So to take the derivative, s prime, the 6 is going to come out front. The 2t minus 1 divided by t plus 2 will drop down to the 5th power. And now I'm going to multiply it by the derivative of the inside, which is going to be the quotient rule. So that's going to be t plus 2 times the derivative of the numerator, which is 2, subtract 2t minus 1. The derivative of the denominator is 1. And this is all over t plus 2 all squared. Again, as far as calculus goes, we're done calculus right here. And now we're going to simplify. So to simplify this one, I have 6. And now this is a fraction raised to a power of 5. So this is, I can split this up into the numerator raised to the power of 5 and the denominator raised to the power of 5. And you will see why in a second I'm doing that. Now, let's clean up the numerator here by distributing the 2 to get 2t plus 4. Distributing the negative sign, I get negative 2t plus 1. And this is still over t plus 2 all squared. Continuing along, I'm going to have 6 2t minus 1 to the 5th over t plus 2 squared. And then, if I collect like terms up here, I'm going to be left with, well, the 2t and the negative 2t cancel. I'm going to be left with 5 all over t plus 2 to the 2nd power. And I see I made a small mistake here. I'll correct that before we go on. This here should have been a 5. Okay, now all I do is multiply, and I'm going to multiply straight across to simplify. So this 6 times the 5 is going to give me 30, and I have my binomial of 2t minus 1 to the 5th. And in the bottom, notice these are like terms, and when I multiply and my bases are the same, I add the exponents. So this is going to be t plus 2 to the 7th power, and there would be your final answer. So again, we start with a chain rule, and then I multiply by the derivative of the inside, which is a quotient rule. All right, let's try this one. So now we're given the quotient of two things. So again, I have 2x to the 4th, and I'm going to rewrite this as 3x minus 1 to the 1/2. Again, I have to use the quotient rule, but when I take the derivative of the denominator using the quotient rule, it's going to be a chain rule. So y prime is going to be 3x minus 1 to the 1/2 times the derivative of the top, which is going to be 8x cubed, subtract the top, which is 2x to the 4th, times, again, this is going to be the chain rule, so it's 1/2 3x minus 1 to the negative 1/2 times the derivative of the inside, which is 3, all divided by 3x minus 1 to the 1/2 all squared. So again, we are done calculus right here. Now it's a matter of simplifying. So 8x cubed, I'm just going to move it in front of the binomial 3x minus 1 to the 1/2. Here, I'm going to do a couple of things. I'm going to multiply these two together, and that's going to give me negative 6x to the 4th. And then I'm going to move this guy, which has a negative exponent, down with the 2. So this is going to be multiplied by 1 over 2 times 3x minus 1 to the positive 1/2. And this is still all over. Now, if I square a 1/2 or square a square root, multiply the exponents, this is just going to be 3x minus 1 to the 1st. Now, some of you might be wondering, why didn't we move this guy right here down to the big denominator? It's because it's part of a binomial, so it can just come to the denominator of the 2 in this term right here. Okay, next step. This guy here is really over 1, so I'm going to multiply those two together. So this first part's not going to change. It's going to equal 8x cubed times 3x minus 1 to the 1/2. Subtract. 6x to the 4th is going to go over top of. So I have 6x to the 4th all over 2 times 3x minus 1 to the 1/2. And this is still all over my denominator, which is now 3x minus 1. Now to simplify a little bit, okay, I have this 2 can divide into a 6 to be left with a 3 there. Now, to simplify this a little bit further, we don't like to have a fraction in my numerator. So just like before, we could factor out a 3x minus 1 to the 1/2, or a 1 over 3x minus 1 to the 1/2, but I think it's easier just to multiply each term by 3x minus 1 to the 1/2. So I'll multiply this by a 3x minus 1 to the 1/2. I'll multiply this term by a 3x minus 1 to the 1/2, and I'll multiply this term by a 3x minus 1 to the 1/2. Now this will clean up quite nicely. So if we take a look, I have 8x cubed. 3x minus 1 to the 1/2 times another 3x minus 1 to the 1/2 is just going to be 3x minus 1. Here, these are going to cancel, and I'm left with a subtract 3x to the 4th. And in the bottom here, you notice this is the same base as this, so I simply add the exponents. So I have 3x minus 1 to the 3/2. And we're very close. All we're going to do is distribute the 8x cubed and collect like terms, and we are done. So this is going to be 24x to the power of 4 minus 8x cubed minus 3x to the 4th, all divided by 3x minus 1 to the 3/2. And collecting like terms, I am going to get 21x to the 4th minus 8x cubed all over 3x minus 1 to the 3/2, and that would be my final answer. So again, you can see it's not so much the calculus, it's the algebraic simplifying that people often have trouble with. All right, let's try one more, and that will be the end of our lesson. So again, for this one, I am going to rewrite the numerator as x plus 3 to the 1/2, and I'm going to leave the bottom as x squared plus 2 squared. So again, I'm using the quotient rule, but when I take the derivative of each term within the quotient rule, it's going to be the chain rule. So it's going to be the denominator times the derivative of the numerator. And again, some of us might be to the point already that we know this is going to be 1/2 x plus 3 to the negative 1/2, and you might be able to go straight to this step right here, because usually you would write your x squared plus 3 to the negative 1/2 up in here. But if you want to move it down to the bottom and make the exponent positive right away, you can do that to save yourself a step. So this could just be 2x plus 3 to the positive 1/2, and then the derivative of the inside of that is 1, so you don't need to write anything there. So there's the numerator or denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which again is going to be the chain rule. So it's going to be 2x squared plus 2 to the first times 2x, and this whole thing is over the denominator squared. So if I square a square, it's going to become a fourth. Now, before we go any further, let's take a look here at one thing. Right now, I know I have 3 terms. There's one term, there's another term, and there's a third term. And if you notice, there are some common factors in those 3 terms. And if we take a look closely, you will see that, let me just get a different color here, there is an x squared plus 1 here, or sorry, x squared plus 2 here, there's one there, and there's another one there. And the smallest power is a first, so that means I could take one of these out from all 3 of these terms. So if I do that, this is going to go down to a power of 1. This guy is going to be completely gone, and this guy here will go down to a power of 3. So now when I simplify, this is over 1. If I multiply those 2 terms together, I get x squared plus 2 over 2x plus 3 to the 1/2. Subtract. 2x times 2 is going to give me a 4x, and that's going to go in front of the x plus 3 to the 1/2. And this whole mess is still over x squared plus 2, and now this is a cube. So just like before, we didn't like having fractions in our numerator. So now I'm going to multiply everything by this. So I'm going to multiply by 2x plus 3 to the 1/2. It's supposed to be a 2 out front. And times by 2x plus 3 to the 1/2 and 2x plus 3 to the 1/2. So now this cancels out with that. So in that first spot, I'm going to be left with just x squared plus 2. Over here, 4x times 2 with a minus sign is going to give me negative 8x. And x plus 3 to the 1/2 times x plus 3 to the 1/2. Bases are the same. You add the exponents. It's going to be x plus 3 to the first. And my denominator is just the product of 2 terms. So it's going to be 2x plus 3 to the 1/2 times x squared plus 2 cubed. Now I'm going to distribute my negative 8x. So I have x squared plus 2 minus 8x squared minus 24x all over 2x plus 3 to the 1/2 times x plus 2 cubed. And now we just gather like terms to get negative 7x squared. So that gets rid of those. Minus 24x plus 2, and this is all over my denominator of 2x plus 3 to the 1/2 times x squared plus 2 cubed. And that would be your final answer. So again, we're done calculus at this first step right here, and then the rest is simplifying algebraically. All right, that concludes today's lesson, and there is your assignment. So good luck with it, and be sure to check your answers on the webpage.